So in the last video we had just finished class example number 1, so now we're going to get into class example number 2. Alright, so you're going to see these questions asked a couple different ways. One way is that they'll give you the two ordered pairs and ask you what the midpoint is. The other way is that they'll give you a picture of the segment and they'll ask you what the midpoint is. So again, I'm going to show you two different ways to do it. I'm going to show you how to do it graphically or how to do it algebraically. So alright, to do this graphically now, since it's already graphed for us, let's just go ahead and go from right to left, from left to right on the line and figure out how far up, cut it in half, how far over, cut it in half. So going up, we'd have to go from here, up 1, 2, 3, 4, 5, 6, 7. Alright, so we cut 7 in half, we get 3.5. So now we're going to have to go up 1, 2, 3, 0.5. So now we're, I hate when it does that. Oh, damn it. Stop. Sorry. Alright, so right there. We're halfway in between. Alright, so now let's figure out how far over we have to go. So from here we'd have to go over 1, 2, 3. And so half of 3 is 1.5. So we'd have to go over 1.5. So now that puts us right, God bless, stop that. Alright, it puts us right here. So we're halfway in between here and halfway in between here. So now trying to figure out what this ordered pair is actually kind of hard. We'd have to go over negative 1.5, so negative 1.5, and then up, negative 1.5, and then up positive 1.5. So up positive 1.5. And so that would be my midpoint. It asked us to find the midpoint. We found the midpoint. Now, if you prefer to do it algebraically, let's go ahead and just write down what these two ordered pairs are. So this is the ordered pair, negative 1, negative 2, negative 3, negative 1, negative 2. So it's the ordered pair. Let's switch colors. It's the ordered pair negative 3, negative 2. Alright, and so then what's this ordered pair? This is the ordered pair over 0, up 1, 2, 3, 4, 5. So over 0, up positive 5. Alright, and then once you have the two ordered pairs, you can add them together. So negative 3 plus 0 is negative 3. Negative 2 plus 5 is positive 3. And then you can divide by 2. And negative 3 divided by 2 is negative 1.5. Positive 3 divided by 2 is positive 1.5. And so, like I said, you're going to get the same answer regardless of which way you do it. It's just which way you're more comfortable. If you prefer the graphing way, go ahead and do it that way. Get graph paper and graph every problem. If you prefer the algebraic way, work them out like this every time. It's whatever way you want to do. Alright, let's do another example. This one says that one endpoint is negative 4, negative 5, and the midpoint is 3, negative 6. And they want to know what the other endpoint is. So this one we are going to look at graphically first because I think that that's easier, and then we will look at it algebraically if you prefer that way. But for the most part, I'm going to do these graphically because I think it's easier that way. Alright, so it says one endpoint is negative 4, negative 5. So negative 1, negative 2, negative 3, negative 4, and then down negative 5. Negative 1, negative 2, negative 3, negative 4, negative 5. So this is one endpoint. Oh, I hate when it does that. Stop. Alright, so this is one endpoint. I'm going to label it A. Alright, and then it says the midpoint is 3, negative 6. So over 1, 2, 3, down 1, 2, 3, 4, 5, 6. 3. Oh my God, stop doing that. I've got to find out what it is that's making that happen. Alright, so that's the midpoint. So this is part of my segment, but I know that my segment has to keep going because this is the midpoint and I want the other endpoint. So if this is one endpoint, the other endpoint would have to be down here somewhere, right? Alright, so what I'm going to do is I'm going to figure out how I got from this point to this point, and then I'm just going to keep counting to figure out what this point would be down here. So to get from this point, I have to go down 1 and then over 1, 2, 3, 4, 5, 6, 7. So to get to my other endpoint, I would need to go down 1 and then over 1, 2, 3, 4, 5, 6, 7. So this would be my other endpoint. I'm going to call it B. Alright, so now I got to figure out what this ordered pair is. So this is the ordered pair over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then down 1, 2, 3, 4, 5, 6, 7. So it'd be over 10, down 7. So that would be the ordered pair, positive 10, down 7. So that's a negative 7. So that's how you would do it graphically. Now it's really hard on this graph because the graph ended before I got to my point. But I think you guys will see that doing it algebraically is even more complicated, and so I think you're going to prefer to do it graphically. But that's just my opinion. You could be different. Alright, so here's how to do it algebraically. If I wanted to find the x term, I would need to take my two x values, add them together, and divide by 2. And that would equal the x of my midpoint, right? This would be x of my first point, x of my second point, and then divide by 2 would equal x of my midpoint. All right, well, in this case, they give us one of these pieces, and they give us this piece. So if I set that up and solved it as an equation, I would plug this in for x1, so I'd have negative 4 plus, this is what I need to solve for, is the x of the other endpoint, divided by 2, is going to equal the x of my midpoint. Well, the x of my midpoint is 3. All right, and now you're just solving an equation for x. So start by getting this out of the denominator, so multiply by 2 on both sides, makes this go away, and you get negative 4 plus x is equal to, and 3 times 2 is 6, and then you can add 4 to both sides and get that x is equal to 10. Right, so we got the same x value both times. We got x is equal to 10 when we graphed. We got x is equal to 10 when we solved it algebraically. All right, now let's do the y value. I'm going to try to write a little smaller down here. Y. All right, so the y value of my endpoint is negative 5. So I've got negative 5 plus the y value I'm going to solve for, divided by 2, is equal to the y value of my midpoint, which is negative 6. And so now whenever I solve this, I multiply by 2 on both sides. I get that negative 5 plus y is equal to, and negative 6 times 2 is negative 12. And then I add 5 to both sides, and that goes away, and I get y is equal to negative 7. So now I have an x value, I have a y value, so now I can write my ordered pair of my other endpoint is 10, negative 7. So again, get the same answer either way. It's just which way you prefer to do it. If you prefer to do it graphically, do it like this. If you prefer to do it algebraically, you can do it like this. I think that doing it graphically is much easier, but that's just my opinion. All right, let's do another example. We have one more class example. This says, if M is the midpoint, what is the other endpoint? So here is one endpoint, A. Here is the midpoint, M. They want to know the other endpoint. Well, so where is the other endpoint going to have to be? If this is one endpoint, the other endpoint is going to have to be like down here somewhere. Okay, so I like to try and make myself like a target area, because if I get an ordered pair that's not in this target area, I've probably made a mistake. And in fact, if this is a multiple choice question, plot all of the points and see if one of them falls in here. If only one falls in your target area, then that's probably the answer, and you can just move on to the next question. But okay, if M is the endpoint, if M is the midpoint, what is the other endpoint? Well, so the way I would do this graphically is I would say, how did I get from here to the midpoint? Well, I had to go down 2 and over 1, 2, 3, 4. So to get to the other endpoint, I'd need to do the same thing. Go down 2 and over 1, 2, 3, 4. So I get this point right here. And so the question's asking, what is this ordered pair? Well, this ordered pair is 1, 2, 3, 4, 5, 6, down -1. So the other endpoint is 6, comma, -1. Now, if you prefer to do these algebraically, you can go ahead and try it that way. I'm not going to show it that way again. If you are an algebra person and you want to do these algebraically and you want me to go through some more examples with you, I will. Just make sure you come and ask me. Alright, let's move into the student examples. Alright, so go ahead and pause the video and try this problem. There's graph paper available if you need it. And when you are ready and you have an answer, hit play and you can check to see if your work matches mine. Alright, it says find the coordinates of the midpoint of the segment, and they gave you the 2 endpoints. So you're looking for the middle point. So there's 2 ways to do it. I'm going to start by showing how to do it algebraically. So you could have gone like this and lined up your 2 points, and then you're going to add your points and divide by 2. So if I add my 2 points, 4 plus 5 is 9, -2 plus 8 is +6, and whenever I divide by 2, I get 4.5, and 6 divided by 2 is 3. Alright, so that's one way to find the midpoint, is to line them up, add them together, and divide by 2. Another way to find the midpoint would be to graph it. So I've got the point 4, -2 over 1, 2, 3, 4 down to this point right here, and the point 5, 8 over 1, 2, 3, 4, 5 up 1, 2, 3, 4, 5, 6, 7, 8. Alright, so I've got these 2 points. Alright, so if I figure out how far up or down I have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that right? Yeah, that's right. Sorry. And cut 10 in half and I get 5. So I go up 1, 2, 3, 4, 5. That puts me on this line right here. Alright, and then how far over do I have to go to get from here to here? Well, I only have to go over 1, so half of that is 0.5. So now I'm at this point right here. Right, and so to figure out this ordered pair, I have to go over 1, 2, 3, 4 and a half. So that's 4.5. And I have to go up 1, 2, 3. So it doesn't matter whether you do it algebraically or graphically, you get the same answer either way. Alright, let's go ahead and stop this video. We'll do the last 2 student examples on the last video.